p. Now what is the maximum height of the projectile motion? Well, consider a ball. Let you kick this ball and it starts moving with initial velocity of 50 meters per second and parabolic path. Let its motion form 30-degree angle with x-axis. Now this is the vertical position of the ball from the ground. This is also the vertical position of the ball from the ground, but this is the highest vertical position of the ball from the ground. From this point onward, the ball falls down. Thus, this highest vertical position of the ball is known as a maximum height of the projectile. Therefore, we define the maximum height of the projectile as the highest vertical position of the object from where it falls down is called the maximum height of the projectile. Let me repeat it. The highest vertical position of the object from where it falls down is called the maximum height of the projectile. Now in the first part of projectile motion, we learned that this ball moves in horizontal direction and its x component of velocity is ux is equal to u cos theta. Also, it moves in vertical direction and its y component of velocity is uy is equal to u sin theta. Secondly, we learn that at maximum height, the y component of the initial velocity becomes 0, but the x component of the initial velocity is not 0. If you do not understand all these concepts, then watch the first part of projectile motion and its link is given in the description. Now I am interested to derive the equation of maximum height of the projectile motion. To do so, I divide the motion of the ball into 3 points P, Q and R. P is the initial point of the projectile, Q is the maximum height of the projectile and R is when the projectile hit the ground. To derive the equation of maximum height, we take the displacement of the ball from P to Q in y direction and we neglect the motion of the ball in x direction. We know that the initial velocity of the ball in y direction is uy is equal to u sin theta. The final velocity of the ball in y direction at point Q is vy is equal to 0 meter per second. The acceleration of the projectile is a is equal to negative g. These all parameters are joined by the equation 2as is equal to vf squared minus vi squared. R2 and to negative g and to h is equal to the final velocity of the ball is 0 meter per second minus and the initial velocity of the ball is uy is equal to u sin theta squared. This negative sign and this negative signs are cancelled out. We get 2gh is equal to u squared sin theta squared. Rh is equal to u squared sin theta squared upon 2g. This is the equation of maximum height of the projectile. Remember that it depends upon sin theta and initial velocity uy of the projectile. Finally, let me teach you one exam-based numerical question. For example, consider that a ball is thrown with a speed of 50 meters per second and a direction 30-degree angle above the ground. Find the height to which it rises. Well, let me write the given data. The initial velocity of the ball is u is equal to 50 meters per second. The angle of the object theta is equal to 30 degree. And we know that g is equal to 9.8 meter per second squared. The required value is the maximum height h of the ball. The equation of maximum height of the projectile is h is equal to u squared sin theta squared upon 2g. Now plug in all these values in this equation. After calculation, we get h is equal to 31.9 meter. Thus, the ball will rise to 31.9 meter if we throw it with initial velocity u is equal to 50 meter per second and a direction 30 degree above the ground. I hope that you have understood the maximum height of the projectile.